Well, hello everyone. Welcome back, and good morning, good afternoon, good evening, based on the time zone that you're joining in us from. Super excited to talk to you once again uh, for this really exciting episode that we have for you today. Uh, Before we begin, let me just give few things, like talk about few things about the Neo4j and community. Just to begin with. A quick round of introduction about myself. My name is Sidhan, but you can call me Sid. I lead developer communities for APAC at Neo4j. Currently living in Bangalore, but my hometown is Delhi. That's where I was born and brought up. Did my schooling over there. Previously worked with Google, IBM, and two more startups, and bring along with me roughly a decade of experience in community building. By the way, that's the QR code for my Twitter handle. Oh, sorry, my X handle. If you wish to stay connected with me in future. Okay. Uh, Quick note on Neo4j. If you're joining us for the first time and not sure what Neo4j is, Neo4j is a graph database and analytics company. We are the market leaders in this category. Um, the idea for the property graph model Neo4j was conceived on a flight to Mumbai. That's one thing which I'm really proud of the fact. A co-founder and CEO Emil Ephraim was traveling to IT Bombay for one of his research projects, and that's when he conceived this idea on a piece of paper, on a napkin, while traveling to Mumbai. Uh, the product was started in 2007 and has evolved since then from being an open source community edition to being an open core model having a closed source enterprise edition as well. And you can use it on Docker desktop, or you can use it on Google Cloud Platform, Azure, or AWS. Well, if I'm super excited for this session, and if you too are excited for this session, you can win this awesome Neo4j t-shirt that you're seeing on your screen. And to do a simple task, which is tweet about the session, how excited you are for this online session. Tag me, that's my Twitter handle, my X handle, uh, and Neo4j, and use this hashtag graphs at everywhere. For today's session, we have a really exciting speaker, Dr. Sixing Huang. He is working with Gemini Data Japan. He's also one of our Neo4j Ninja. And today we want to discuss around knowledge graphs for personalized medicine. Without further ado, I'd like to bring Dr. Sixing Huang over here. Hi, Sixing, how are you doing?
Hi, good, Sid. Thank you for the invitation. I'm excited to be here.
Great. Likewise, I'm looking forward to learning a lot of exciting things from you, especially in the field of healthcare and medicine. How do we utilize graphs potential and plug it with healthcare and medicine industry? So, looking forward to it. Before we begin, I would love to know a bit more about you. I know that you are a Neo4j ninja, but I would love to know a bit more than that. And specifically, I would love to understand how your journey with graphs started. When was the first time when you fall in love with graphs?
I first met Neo4j during my postdoc career in Germany. So at that time, I was doing research in TSMC Braunschweig. So at that time, we had a large data set of genes and gene expression. So the question is, how can we find meaningful relations among the data? And then Neo4j came into my life. So at that time, I used Neo4j first to store and then analyze data. And since then, I was like on the good path with Neo4j and use it for many of my projects since then.
Wow, that's an interesting story. So, from an that was your postdoc project, or was it your
Yeah,
doctorate? Okay.
postdoc.
Okay, from postdoc project to now using Neo4j in the professional capacity, and
Yes.
yeah, and you've been really active in this entire space, contributing a lot to the graph developer ecosystem. Really looking forward to understanding more about what you're going to talk today. I know this for a fact that this is a chatbot, but I will let more questions come in from the audience in a while. Uh, and let's dive into the topic a bit. Would want to understand how does knowledge graphs play a role in healthcare industry? One, and the second thing is why you chose healthcare industry specifically? Why not any other industry out there?
First of all, I come from the biology medicine background, so it was natural for me to start to combine this graph technology with the biomedical science. So because during the projects, it occurs to me that um, doing a good knowledge graphs is so you need several skills. So programming in graph skill and linguistic, and first of all, actually domain knowledge. So it's not just say that we can put together some APIs, then we have a knowledge graph. Is that the author needs to have a good understanding in linguistic and domain knowledge. So I think it is better to pick the battlefield that where we know the most about. So for me, it is biomedicine.
Interesting. Nice. Cool. Sounds good. Thank you for giving that context. Really puts this context in place and understanding a bit more on the topic. So let's dive further and understand a bit more on the amazing work that you have done. How about it?
Okay. Yes, thank you. So good afternoon, good evening, and good morning, everyone. Today, I would like to talk about my open source project called Doctor AI. And this project was started in 2020. So in terms of this LLM era, it is really like a prehistoric project. So during this process, I have added some new features. So now later it became this Bayesian Doctor AI. So it is basically a graph-based medical chatbot with the decision device. So you will see, and that is targeted at personalized medicine. So first about myself. So as Sid has introduced me, I am Sixing Huang. I come from the bioinformatics field. So I also blog, and I was honored to become a Neo4j ninja. Currently, I work for a company called Gemini Data Japan. So it is a no-code graph platform that redefines how the graph data is understood and shared. It makes the data more accessible, usable, and valuable. So this platform is an integral part now for my projects. So I will use it very often to visualize and explore the data sets. So first of all, the incentive. Why use knowledge graph in medicine? Many of you know that between doctors and patients, the patients are the minority group. So they knows the least and they have relied on doctors' decision. So in this information asymmetry, so the patient will have to learn a lot more about their own situations. So in this case, they will need some um, authoritative data and knowledges. So we need some service to simplify complex concepts for the patients. And secondly, currently there are a lot of public databases online. We need to, however, plug our personal health information into this vast network of knowledge. And in this era of personalized medicine and big data, on the one hand, we want to protect our own privacy. So we don't want any other people to know about our age and other situations. However, we also want to contribute to the medical research with our data. So how can we balance this privacy and public research? So one of the possible way is to use some probabilistic models. And also because it's personalized, so everyone should have their own knowledge graph. So my knowledge graph should be very different from Sid. And how can we do that in a knowledge graph currently? So then we need something called a probabilistic model. So then we can play around with the model, we can sandbox the experiment. And what's more, because we have a lot of cost benefit analyzed. So should we take this drug? Should we go to this hospital? Should we take this test? And it will always come with a cost. So for each one of us, our willingness to pay is different. So for someone that has a lot of financial resource, he will may take the most expensive drug. While for the rest of us, we sometimes we want to have something like that we can afford, but it's also effective. So how can we give each individual a clear judgment, a device to make this calls? So like I said, the incentive is to democratize and personalize these medical KGs. There are a lot of knowledge graphs now, but only experts can use them right now because not everyone is programmer. And even for programmers, Cypher is a new language, so few can use them. Yeah. So the question is,
that's why you thought of building more like a chatbot mechanism where
correct.
the patient can interact, but at the same time contributing to the KG. If
Exactly.
I'm okay, great,
Exactly. Because even Cypher, it still takes time for you to learn how the graphs looks like. So it is not very straightforward. But let's say if we can have something like a chatbot, it can encapsulate everything, and it kind of acts as a middleman. And also, voice is much faster. So, for example, in Chinese or in Japanese, voice is like 2 to 3 times faster. And there are situations that you cannot use your hands. So in surgical rooms, that's free labs. So you would like to have a voice control device and also no code interaction. So that is the reason that why we want to have natural language interaction. So
right,
the concept was like in 2020, it was like it's kind of relatively new because at that time GPT-3 it was before the beta. So and however after GPT-3, everybody knows the whole industry now comes into LLM era. So
yeah. So I have two questions over here. Um,
Mm.
First one is you said that voice is faster than typing, which basically means the chatbot is voice powered, or is it combination of both voice powered and like typing the text?
Uh, in the Doctor AI project, I offered the so-called Alan Studio voice to text engine. So it is like very accurate transcription service. So I can
Okay.
speak to it and it kind of can correct the transcription based
Okay.
on the whole sentence. So so it is possible. And if you say, okay, I can type better than speaking, because sometimes maybe the transcription will mishear some words, then I still have the chance to correct them in the input box.
Right.
So yeah.
And another question is, does it only support Chinese and Japanese if we are going with the voice option?
The base language is actually English.
Okay.
So there is a reason for this because the majority of the data in the knowledge graph are
It's in
English.
English.
So yes, so the database will be completely in English. However, so there are two ways to solve this multilingual problem. So one way is you keep the database in English, but then you only translate the language
The
interaction
yeah.
back and forth. yeah, that's the first one. The second one is like a complete localization. So if you have a Swedish customer and he will only use Swedish for the whole service, then you have to translate the whole database also into the local language. But that comes with a high cost. So you need to maintain the database to make sure that everything is localized correctly, and you have to also incorporate the newest finding from English to your local language. So I prefer the first option. So because you do not have to change the database. So the same database can serve multiple languages, but you will risk some loss in translations during the natural language to cipher.
Got it. I think this
Yeah.
sounds interesting. I'm not sure if it is already there, so they're integrated into the chatbot right now, but there could be a possibility that the database remains in English. The data remains in English. You're using your own language. Let's say in India there are plenty of those regional languages. So I communicate with the chatbot in my regional language, and if in case the NLU is trained in that way, um, it converts the regional language to English, English to text. I know it's a longer process. English to text. Text will then be passed to the database for the querying. Comes back the results in the textual format, goes for translation again and gives the result back in the same language. um yeah, I don't know if it is something, but yeah, uh let's understand a bit more. Just one more question before we move on and understand how the platform really looks like. You mentioned that the advantage of chatbot is that there's hands-free interaction in surgical rooms and dust-free labs, which I'm guessing that this chatbot is not only for the patients, but also can be used by the practitioners, by doctors, by surgeons, by lab assistants, or anyone out there. So you're actually like putting the entire ecosystem of healthcare industry under a chatbot realm. Is it correct to say that?
Yes. So because there are situations that like the hand-free interactions is a must. So and that happens a lot in this clinical setting. So the hygiene, where the hygiene is the utmost important item. So to be able to hand-free, that makes the application much more, so it is sanitized, and then you can use it in very hygienically strict setting. So that will make the chatbot even more powerful.
Got it. Interesting. Super. This sounds good, Sijing. I think I'm
Cool.
really looking forward to see how it works in action. How does the interface looks like? What's the architecture behind it? I'm curious.
Yes. So the interface looks so we have several interfaces now. So this is our first interface. It was developed during the 2020 DataFon in Singapore. So for Neo4j engineers, directing Shiny Ju and Amu and also Ivan. So we four developed this chatbot in a very short time. And the first interface, it was based on the React Simple Chatbot project. So as you can see, it is HTML based, and then this HTML based chatbot basically allow us to input the question and also can accept our voice. So it will transcribe, and then it will kind of the transcription will appear in the input box. And then when the user press the enter key, the chatbot will try to answer this question. So that is the interface, of course. So behind the scene, actually, it is also, let's say, quite straightforward. So on the right-hand side, you can see the users. So both the doctors and patients, because depends on what you put into the knowledge graph, both the doctors and patients can query it. And the interface is like the front end you have seen. Also, if we enable Alan Studio, that will transcribe our voice into text. So this information, this natural language, it will go to the GPT-3 at that time, and GPT-3 will translate the question into cipher, and then cipher, it is the communication language to Neo4j. So once we get the cipher, we just go to the EC2 Neo4j instance, get the answer back, and then we can either summarize it again with GPT-3, or we can just present this information back to the user. So on the back-end side, the knowledge graph is actually a mismatch of several public knowledge graphs, including the EICU, HTML, KEGG, and string. And of course, if the user wants, they can also integrate more data into this back-end knowledge graph. So also, one final point is that this graph, they are basically still static. So if you do not have your own data, you have to wait for the next update to see the newest research. So can we do something? Yes. We can also use GPT-3 to ingest some of the research articles and then input it into the backend in order to keep the knowledge graph up to date, so that the users will find the newest information from this system.
Interesting. There's a very nice question by Daniela on the in the
Yeah.
comment section, and I was just about to ask the same thing. How do you ensure the information is factually correct?
So because that is the question of the authoritative data source. So because here we do not rely on GPT-3 for the answers, so we do not suffer the hallucination effect from GPT. The answer actually comes all from the knowledge graph. And currently there is a term for this, is say retrieval augmented. So basically the GPT-3 here only acts as a translator. It translates the natural language into the query language. So by extension, you don't need a knowledge graph here. You can have a SQL. You can also have like a vector database, if you like. So the GPT-3 only kind of translate this language back and forth, but the answer always comes from your trusted database. So you can control the quality of the answer by controlling the quality of your database. So you only let the high qualified curated data set in your backend. And that is how you, that's one way how you can make sure that the answer is good. And the second is, I will mention it later, is called a chatbot ensemble. So the idea is you will have several chatbots and they work differently. So one maybe is like Dr. AI, the other may be a GPT-3, which is not very reliable, but still sometimes it makes sense. Maybe the third one is completely PDF based. So you may have something like a vector database. And then when they all answer the same question, you kind of, okay, please summarize and consensus the answer, so that the user can have like, okay, so what does Dr. AI say? What does GPT-3 say? What does the vector say? And then he may have a complete picture of the answer. So we kind of neutralize the hallucination effect of the LLM in this case by using different mechanisms. So that is the second way. So basically you can add to your authenticity, your trustworthiness by using trust data, but also consensus.
Got it. Interesting.
So yeah.
You're currently storing it on AWS, is it? The database is
Yes, but you can save it. You can store the data anywhere. So because you can also have the data set on your Neo4j desktop.
yeah.
So on Neo4j, on EC2, we use it because at that time we have the enterprise. So that also speaks to, that also will be depending on the user. So if you have like a large enterprise organization, so you may want to have your graph or more hardware, and then you have to kind of deploy them more reliably on the cloud. And then, but as long as it is exposed to the front end, so really the front end doesn't really care whether you store it locally or on the cloud.
Got it. Interesting. And how does this tag text to cipher conversion works? The GPT-3 to
Yes,
conversion works.
yes. So I have to say, at the time of this project, it was like the one reliable way of doing this is by learning by doing or learning by examples from GPT-3 at that time. So basically, I compile a list of questions, cipher, question, cipher, question, cipher pairs. So as you can see here in the big box, the two, paste your English cipher examples here. That is where, let's say, my examples are. And GPT-3 will read these examples. And then afterwards, here comes the generative AI part. That is where I put my question. So at the end of this whole example box, I will pose my challenge question. So tell me something about the disease called COVID-19. And then GPT-3 will generate the answer. So this is called the few shot mode, now is known. And it will kind of generate very accurate cipher for me. As long as I provide enough examples above. So at that time, this is one of the way that can be producing very high quality cipher. But nowadays, of course, we have LangChain and other plugins from Thomas Batanik, so that we don't even need the examples because the plugin will read the schema directly from the database and figure out everything, the no labels and the relation labels, and is capable of generating all the cipher on its own without this example box. So that is amazing. So this is how the translation will work. So like this is how the GPT-3 will look like. Of course, the plumbing occurs in the front end code. So the front end needs to transfer the user input the question to GPT-3, and then the GPT-3. So if you have different languages too, so if you have in this slide, you have German, you have Chinese, Japanese. So GPT-3 will kind of first translate that into English, and then later to cipher. However, nowadays we know that with effective vector embedding, maybe we don't even need this translation anymore because the search engine will kind of project this German question into the same space like the English question. So kind of the LLM will have the like a universal language understanding. So it doesn't really matter now whether that is in Chinese or in Japanese, because internally it is kind of the same vector space as the English question. And after the question, the GPT-3 will be able to map this question into its corresponding cipher. And because then this cipher is all we need for the Neo4j. So as long as the cipher is correct, then we will get the answer from because at least half of the users will be patients. So they may not want some very academic explanation from our research articles. So they want something that is simpler to understand. So in this case, I also built in like a explainer, so an ELI5. So basically, it just summarizes the very long academic text into something easier, so digestible, so for the average readers. So then they will get something from this interaction, not just, okay, just give me an info dump and let me Google. No. So it's possible that they will have a simpler explanation, so then they can get more out of this interaction.
Got it. Pretty interesting. And there's a question by one of the participants over here, attendees over here. Here, the patient and
Yeah.
doctor communication of voices will be collecting through GPT, and it's converting the text data. So how it's taken, how it's identify which one is important issue of the patient. Um, I think it's not a communication between patient and a doctor. It's more of the communication between the chatbot and the patient,
Yes.
or chatbot and the doctor. um,
Yes.
so the data might be coming in as a voice input, or it can also be coming in as a text input, depending on what. If it's a voice input, it gets converted to a text and then passed to Neo4j, for
Yeah.
like words to cipher, and then cipher to Neo4j, and then Neo4j back to cipher in the form of cipher, and then back to the user in the form of text prompt. Uh,
Correct.
if it's a voice, I think it converts. It first understands the natural language, and then tries to convert that voice to text, the text to cipher, cipher to Neo4j, Neo4j back to cipher, and then to text. If I'm not wrong on that.
Yes. Of course, the chatbot can also speak. So it is kind of, yeah. The difficult part is actually the voice to text. The text to voices, we now have really very good voice synthesizers. The difficult part is because many users will speak with various accent and
Dialects are
vocabulary.
different.
Yeah.
Yeah. And
Yeah.
oftentimes I've also seen the context in which the sentence has been put in is also very different. So if even if I'm speaking in English, the way I say a sentence would be very different from someone else who says the same sentence. Like,
Exactly.
won't communicate the same thoughts, not the same sentence, but want to communicate the same thought. The other person will communicate it differently, will have different stress on different words, will have different way of putting different words, so they might move some words here and there. So yeah, but ultimately want to communicate the same thing. So it's very difficult from voice to text. The text to voice is fairly easy to do it.
Yeah. As long as you have the script, the synthesizer is very lifelike right now. So basically, you can't even distinguish whether the speaker is a machine or is a human nowadays. So
That's right.
that is let's say the canonical, the original Dr. AI, because it was like 3 years ago in the area of LLM is like prehistoric.
GPT era.
So yeah, exactly. Because at that time we use AWS Lex. So it's like the RASA. So basically, before GPT, let's say, we have to code all the intents, the slots, and so we need to guess what the user wants to ask, whether he wants to ask a certain disease or what kind of drugs. So first, the bot needs to classify the intent of the question, and then it will fill up the necessary slots and then it will synthesize the cipher at that time. So the code is really long, very hard to maintain. And then 2020, everybody knows the beta of GPT-3, and then the code shrinks a lot. So basically the code base is much smaller. And it only takes a very short few lines of code, and then you can already have a very good cipher. And also because the computation is very much on the GPT-3 side, so the maintenance is also easier. Of course, that is when you get information out of the chatbot. But now, what if we want to put information into the chatbot? That is actually a much more difficult question because relation extraction and entity extraction is a challenge, especially relationship extraction, because it involves how you want your knowledge graph look like, because the AI, the open AI cannot guess what you put on the graph labels, the relation labels. So currently, like GCP natural language processing, the NLP API can extract the norm entities really well. It will correctly guess, for example, Germany vs England in the football match. GCP NLP will correctly understand that in this case, Germany and England is not meaning the country. Instead, it means the football team. So the NLP can do this really well. However, it is very hard for the NLP to put relations between these norm entities. So what do you want to connect them with? So in this case is the arrow here. Yeah. So especially also in healthcare, you have a lot of norms entities that are only maybe the academics, they know what that means. So it is a very specific vocabulary. So then the question is, can we also use GPT to extract this so-called subject verb object or subject predicate object out of the text? Mm-hmm. And then we can input them into Neo4j, so we can keep Neo4j up to date. So I tried that. Yeah, I tried that. So it's very similar to this box. So instead you provide a lot of examples how you would like the extraction looks like. And then in this case, for example, in this example, I will say, in this sentence, I will extract the EGF as the subject and the upregulate as the verb, and then MIR 31 as the object. And then when you have a CSV like this, the import into Neo4j will be very easy. So it works reasonably well. And in the case of some simple text, I can basically have reduced the labor a lot, but I have to admit it is not a complete automatic pathway pipeline. You have to still manually check a lot of these relations. Maybe by the introduction of the OpenAI functions, we can make it even more structural and better, but still, I will not be saying, oh, this pipeline can completely get rid of the human. It kind of reduces the workload. It cannot replace the workload. So I will say still keep the human around, but you reduce the human workload by maybe 40%. So
and
I will say this.
Like faster decision making, or at least do the preliminary analysis based on the symptoms, based on the inputs. If the patient really wants to consult a doctor, or what kind of a doctor the patient really wants to consult, that could be a possibility. What do you think?
Yes, as long as you put those information into the graph, and you can even kind of run some GDS on it. So give me a recommendation, do me a collaborative filtering, and so on. So here it is very strictly like information retrieval. So no heuristic, because that will requires a lot of like testing and so on. So it is a very sensitive area. So what if you make a mistake? So let's
Yeah.
say, what if the chatbot gives you some wrong advice? So whose fault? So is the user's fault, the chatbot developer's fault, Neo4j's fault, or even maybe high nature? So
Yeah.
so it's very hard to define the responsibility. So on the safe side, we can use this technology for some non-vital missions, something like logistic,
Hmm.
for the forestry, or maybe something. But for healthcare, it is under very strict scrutiny, so that whether your product will be actually safe, do no harm. So that comes to maybe, again, back to the question, how can you trust the answers from such a system? So we have to put several safeguards in this process. One of them, of course, is trustworthy data sources. And the second one is a chatbot ensemble. So if you do not trust a particular chatbot, you can always ask a second opinion, even a third opinion from the other chatbot. So we know that GPT hallucinate a lot, because it's basically more like its first primary task is to generate correct sentence and then facts. So maybe it is not the most important task for GPT at that time. Was well, it wasn't the truthfulness, so the factfulness. It's the language. But okay, we know that. How can we uh, alleviate that issue? So we still want to use it, but how can we use it more intelligently? So then in this chatbot ensemble, we can build like a small group of chatbots that includes Dr. AI, Kendra, and GPT-3. And Kendra is like an AWS service. It is basically like currently the vector database. So you put in a bunch of PDF inside Kendra, and Kendra kind of do a like an index, like a search engine on your PDF. So if you ask a question, it will try to match the documents that can contain this answer, very similar to vector database. And from these three chatbots, we can get maybe three different answers for the same question. And then we can ask GPT to compile them again into one uh, like a unified answer. And then the user can decide whether he can trust these results. So for example, there are two modes. One mode is a statement mode. So if you ask what is lung cancer, of course, you will get back a statement. But that statement will be like a consensus statement out of the three chatbots. But if you ask something else, for example, what medicine can we use against COVID-19? Most likely we'll get a list of medicine from all these three chatbots. And in this second mode, the summarize will be a list with a corresponding trustworthiness score. For example, in this case, the Remdesivir has a score of 14, which means it has been mentioned by all three chatbots, so it gets a higher mention score and thus more trustworthy. While the hydroxychloroquine, which is mentioned by Donald Trump alone, is not very trustworthy in this case. So then the user can get an intuitive impression about how likely that answer is will be useful. So but again, the final judgment falls onto the user, unfortunately, because this is not exactly like a knows-all machine, and nobody can say that. But informed decision, that is all about informed decision. So the best we can get from the system is this answers. So it depends on how you want to make the most out of it. So that is the chatbot ensemble solution.
Oops, I was on mute. Sorry.
Okay.
Um, so how does the Bayesian part came into picture with Dr. AI? You said that it was a
Yes.
Dr. AI the canonical version, and now it's more of Bayesian
Yes.
Dr.
Yes, because first of all, currently all the knowledge graphs are basically general. So we download public data from database, make them into a graph, but that graph is the same for everybody. So a copy for you, see a copy for me, Sixing, they will be identical. But in this age of personalized medicine, it should not be the case because our hobbies are different, our habits and our health status histories will be different. So how can we incorporate this kind of personal information into the graph without changing the structure of the graph? So you and I can have the same graph, but the details, we can change the node status in the graph. And because that is a graph, so it kind of gets a rippling effect. So if you throw a stone into the water, it will get ripples. The same goes for the graph. If you change the status of one node, the whole graph should get also the updates. But unfortunately, currently, Neo4j's graph cannot do this dynamic updating. So we need something else. In this case, the good old Bayesian network can help. So a Bayesian network is basically called a decision network. So from the name, you know that this device helps us with decisions. So a Bayesian network looks very much like a bona fide graph. So basically you have nodes, but in this case, the nodes are so-called decisions. So for example, in this slide, you can see there are two decisions. Go to Asia, smoke. And then there are nodes that are called outcome nodes. So what if you do these things and what will be the outcome? In this case, get COVID. But the status of the nodes will be different, depends on how you act on the decisions. So for example, if you have like a population, so not a single individual, but a population, then the so-called prior. So what do you have when you, so if you do not ask a specific person, but instead you have a general population, the prior will be the average likelihood, the average situation of the population. For example, in this city, 99% of the population hasn't visited Asia, only 1%, but half of them are smokers. And then based on Bayesian theorem, so we can calculate the so-called posterior probability of getting a COVID. So we can encode the likelihood, the prior into the graph, and then the graph you kind of calculate the COVID infection rate. For us, in this case, is nearly 50-50%. So basically, it's just a good old Bayesian theorem, but in a graph. So you have prior, you have likelihood, and then you get the posterior. So that is the simple concept. But this is the initial form. So it means if you know nothing else but just the general population, that is what you get. So that is what this general population is in average. 50% of them will get COVID. However, if we want to now do personal things, I'm not general population. I'm this concrete individual. I have my own history. So what will happen to me? I'm not interested in the population now. So first, in this new slide, let's say, let me just expand this example a little bit to include something like 3 more diseases like TB, lung cancer, bronchitis. And then when we get the lung disease, then we will show up some lung disease symptoms. So that is what the left part looks like. But now a patient, for example, me, go to the doctor. I tell him I have been to China. So the yes in the visit to Asia box should be ticked. So the doctor can do that. And then if I also smoke, then the yes on the smoking should also be ticked. So that's what you see on the right side of the graph. And as you take these two boxes, they become gray now. The posterior probabilities in the graph will change. All the other boxes will change. As you can see now, the COVID infection from 50 on the left side becomes now 95% because I do all the bad things, let's say. So, but still, you can see how the possible causes changes. So, because most people will think, oh, I don't feel well, do I get lung cancer? Because people tend to think the worst first. But now look at this picture. Okay, you still, yes, you get chance, you get some odds for lung cancer, but it's not like the most likely possible cause. So you don't need to be panicked right now. Yeah, I can't say later, but at this time, COVID may be your major concern. So, and then the doctor, based on this result, can also order the test follow this priority. So the doctor won't check you for your tuberculosis, TB first, because that is maybe in this case the least likely. So the first thing he will test is COVID. So basically it prioritizes the action list. And also for the patient, they can put their expectation correctly. So lung cancer maybe, but first you have to worry about COVID. So that is how this graph now turns from a public to a personal graph, because that reflects your own situation. But of course, this is a simple graph. For a real patient, you have much more boxes. For example, do you do sports? Do you take certain kind of medicine? Or if you have your genomes, you can also may have this information inside this graph. And this structure, this Bayesian network, can reflect your specific, your unique combination of factors, and then predict, kind of calculate the probability for each possible cause. So then you can have a very general overview. So that is the thing. But the beauty of Bayesian is that you can do things backward. Let's say we are sure that you have lung disease because your X-ray, for example. Now input this information into the lung disease box. So okay, click yes in the lung disease. Now it turns gray, means it is now an observation. And then you can see on the left side, okay, the possible causes are the three: TB, COVID, and lung cancer. Once you take the yes in lung disease, the odds for these three boxes also change. Again, COVID is the most likely, and then followed by lung cancer and then TB. Still, lung cancer is not likely to be your primary, but maybe the second. What happens if now the doctor ordered the test for the patient for COVID and then the lung cancer? What if both of the results are negative? So we enter again these results into the COVID and lung cancer box. Take the no and no. And now you can see the TB box from the previous 0.01 to now 1. So on the left side, TB is the most unlikely. So it's the least likely possible cause. But after 2 tests, it becomes the only remaining plausible cause for this ailment, for this ailment of the patient. So again, that reflects what Sherlock Holmes once said. So if you eliminate all the impossible, whatever remains, however improbable, must be the truth. So TB is such improbable at the beginning, but now it becomes the only plausible because you eliminate all the other impossible causes. So that is how Bayesian kind of guides you through the thinking. And this is, so you can have your priority, and then you can do the medical test, and then you will come to your diagnosis by following this process. So the thing is, afterwards, we can embed this Bayesian into a large knowledge graph. So because this Bayesian network in this case is only for lung disease. However, if we want to bring more context to this, let's say the lung disease case, we can add some non-Bayesian nodes. For example, we can add the organs where this disease occurred, for example, the lung and the bronchi. And then gradually, when you add more nodes, these non-Bayesian and Bayesian networks will merge into a large knowledge graph that may include several Bayesian subnetworks and many non-Bayesian networks. So again, Seed and Sixing will have the same graph, the same structure, but as you enter your own data, your own test values, your own life histories, the graph will reflect your personal information, will reflect your own status. So you and I have the same structure graph, but at the same time, you and I will have a personal graph that only applicable to you, and then mine is only applicable to me. So, and then we can also learn a lot of context. So not only this lung disease, but also where does this disease occur and what kind of medicine can we use against this disease and so on. So we can bring everything together. And that is how I think the Bayesian knowledge graph can help in this personalized medicine.
This is interesting. Really, really amazing work over here. And beautiful explanation. I learned a lot today on this. Um, we're actually running short of time. I didn't want to interrupt you while
Yeah,
you were explaining the entire concept, and I would have loved to extend it further. We're actually running short of time. So, in the interest of time, shall we just quickly wrap up the explanation part and then just take up some of the questions in the chat window? There are plenty of those questions, like amazing interaction.
cool.
This is by far the most interactive session that I have seen on the chat window. So
Thank you.
I'd love to take up some questions over there from the chat. So
Yeah,
yeah,
I love to.
yeah, if you can take.
So very quickly, then let me just finish, and then we will have plenty. So by extension, that's actually the Bayesian knowledge graph can be extended into a so-called cost-benefit analysis. It's the same Bayesian network, but in this case, we calculate cost and benefit. And then, for example, in this case, COVID, so a lot of us needs to make decisions during the pandemic, whether we take the test, and depends on the result, should we take the cheap medicine, the expensive medicine, and no treatment. So this Open Markov can calculate these so-called strategies for different people. So let's examine only two of them. So on the right-hand side, for the one that has a low willingness to pay, so basically for the poor strata of the society, they may not able to afford the test. So surprisingly, the best option for them is do not take the test and do not receive any treatment, because money maybe for them is more important in this case. But for the other who can afford this, even for some extreme rich clients, they may say, okay, not only I will do the test, but also regardless of the test result, I will take the most expensive drug as a precaution. So that has an implication for society, because especially during a pandemic, the state should provide a healthcare for everyone, because especially for the lower strata, they will not go to test, and they will not know that if they get infected, and then not only damage their own health, but also prolong the pandemic. So this small analyze can show us these two extremes and reveal something that is kind of very profound social issues. And also now we have this chatbot thing. As I've said, I use Neo4j as our backend and Kendra, and nowadays you have all the other vector databases as your second source of data, and of course internet. So nowadays it's possible that we can use LangChain to kind of make them all together. So you have one chatbot, but you have multiple data sources to answer all your questions. So that is basically what I want to share with you guys today.
All right. Sounds good. So let's take a couple of questions from the chat. The first one is text to cipher available as an API now? I don't think so. It's
Yes,
available as an API. Or is it?
yes. Actually, thanks to Thomas Platonik, so is another Neo4j ninja. He has written like a LangChain plugin. So try it. It's amazing. So basically, you don't even need the training part I showed. So this whole second the box 2 is not necessary anymore. You just import the library, tell him where is your Neo4j database. He will take care of the rest.
Great. The next one is using GPT, identifying the relevant questions, and out of those search results, based on ranking, most relevant one will be identified along with associated cipher, and in turn used to fetch the answers. Uh, I think it's a part one of the question. The second one part is dynamically generating the cipher by identifying the noun and verb and converting them as most relevant labels and relationship types. Any challenges faced?
Uh, so you mean that is it this question about this relationship extraction? So because extract them as the most related labels and relationship types. Yes. So based on my understanding on this question, so I think the user here asked about ontology question. So if I have a raw text, how can I extract data for my Neo4j? So that is one of the most challenging part because there are two approaches. I think first, either you bring your schema, so your graph database structure into the AI and let AI knows how you would like to label your nodes and your relations. And then hopefully GPT-3 will returns those things according to your label, to your schema. So for example, I know seed. So in one's knowledge graph, it will be Sixing is friend of seed. But in my knowledge graph, is Sixing knows seed. So how do you know is a friend of or is it knows? So that we need to bring it into the GPT-3 prompt. That is one possibility. The other is that you let GPT-3 extract all these triplets and then you post-process them. So you basically synonym everything that is a friend of, knows, acquainted with something, all into your selection of vocabulary. So that is kind of how I want to do it, because the prompt has a limitation on your the token length. So you can't bring a lot of schema information into the prompt. And also, there is no sure way that GPT will follow this schema suggestion strictly. So it's always like maybe you have to have a way to enforce that the vocabulary is it is your vocabulary before you import the data into Neo4j. So that is how I understand this question. I hope I correctly answered it.
Great. Quickly moving on to the next one. Is it just a bit of prompt engineering plus ChatGPT?
Nowadays, if you just use Thomas plugin, you don't even need to engineer too many prompts actually. So I tested Thomas plugin. It works quite well for me actually. You don't even need the examples anymore. So this is kind of the old approach. Nowadays, Thomas plugin kind of get the schema automatically from your Neo4j. So you can change the LLM in your plugin. So you can use GPT-4, you can use 3.5, and so on. But I have to say, since then, the whole field has kind of has a new face, has a new an MO. So you do not do things the same way anymore. You have no modi operandi. So please keep yourself updated with the newest LangChain plugins.
Okay, great. The next one. Okay, that's a statement. That's a statement. That's a statement. Okay. Even till today, to healthcare data is never meeting the quality. In that case, how will this solution cater to this issue that we are discussing about?
Yes, so it is a very general thing. So at least as far as I know, countries, like especially in the developed countries, they are adapting various standards. For example, the fire, and so to make the data more like standardized and more usable. So this is not a total solution. I say it is like just the information retrieval part of the healthcare IT infrastructure. So the quality of the data is basically, is a big issue, but for this kind, a small chatbot, it is just the retrieval part. So it assumes that the data you have in the back end is usable. So the extraction part, so the GPT information extraction part, that is always like, it's not completely a replacement of human labor again. So it just reduce your workload. So this, I would say this solution is not, it's not for the data quality again. So it's more like, it's just to make the interaction, the access more easier for many users, and for those who cannot program, and especially for the many non-technical persons. So the data quality, yes, is never the standard quality, but it's not what this solution currently is trying to solve.
All right. Okay, I'll take up these last two questions in the interest of time. For any more questions that will come up, we'll probably refer them to you
Yes.
later on, or on social media or anywhere else. The next one is the probabilistic weights of yes, no put inside the graph as a type of property in the edges.
Yes. So based on the Bayesian theorem, so you need to input two things: the prior and the likelihood. The posterior, like in this case, the visit to Asia and smoking, and then the box, the bottom right side, that is something you input. So it comes from either from observation. So if you have a large clinic, you collect a lot of this data, you put them into these boxes. And the posterior, the COVID-19 box, that is calculated automatically. So that is when you have this prior and the posterior, you will have this. But also, because like I said, you can do things backward. So if you are already sure that you have lung disease, and then the calculation will go backward to update your prior. So so let's say the data here, many of them are either your personal belief. So I guess maybe 50% are smokers. You can also put them there. So either observation or subjective assessment. So that is also the beauty of Bayesian. So because according to the Bayesian understanding, probability is a subjective thing. It's not a frequency understanding. So, but in this case, you put your subjective or your observation frequencies is also okay, as long as you get something kind of meaningful, that helpful with your decision. That is the main thing. I think the number here, is it really 50, 49, is not that hugely important. It's what the order of the test you will prescribe, that is more important. Or how you set your expectation. Is it lung cancer really your first thing to worry? Probably no, in this case, based on what we know about the occurrence of the disease, how rare is the disease, and so on. So basically, just kind of give you a very simplistic view of the world, because we never have perfect data for all these causes and all the possible causes. So it doesn't include genomes, it doesn't include spots, and so on. So it's always a simplified version of the world.
All right. The last question, does it work well in
French.
French? Is it possible to use it for PDF files to graphs? How does it handle co-references, negation, and such?
First of all, I think it works in many languages now, thanks to LangChain. Including French. I think French is one of maybe the second most well-supported language after English, and then also German, Japanese, Chinese. The way it works is that it doesn't translate the language, I think now. It basically project your question into vector space. So basically, it doesn't matter what your original language is, as long as it has the same semantic meaning, it will get to the same projection space, and then it will be translated effectively into cipher. So nowadays, at least the input language, because the LangChain has various plugins. Some of the plugins, they do not support the output in your local language. So maybe you will ask a French question, but you will get the English answer. It happens. There is some plugins, but the other plugins, like the web search plugin, it will answer you back in your original target language. So French, not French, English. So don't worry about that. So for PDF to graph, so there are two possibilities. One thing is like what I said in here. So you have like a vector database. You basically encode all your PDF into a vector. So that is also the same thing as in here. So Kendra. So basically you put your PDF into a digestion engine, and then you either use it as a chatbot, so its own chatbot, or you use one chatbot to rule them all. So that chatbot will also query the vector database with a plugin. So you can do that either as a chatbot or as a tool in the chatbot. So both ways are possible. So you can try. I tried both, and it works it works reasonably well. So I suggest, however, you try your own. Co-reference. Co-reference only occur when you do the extraction part, this part. That is hard. If you use some state-of-the-art library, it takes a very long time to process even one sentence. So that really sometimes costs you a lot of time. So the co-reference, I think you either do not do it, so you make a large token prompt, so you send a lot of text to GPT, and hope that it will correctly understand all the co-reference. Or if you have the time, you do a co-reference on your machine, and then, but even the co-reference is also error prone. So sometimes it will co-reference the wrong none. So it is also, so it is a very delicate balance. Do you want to introduce more errors during the co-reference, or you just skip it? Or GPT-3 all the way from raw text to knowledge. So it's your call. In this case, negation, I think it's okay, but depends on if you want to extract that also into your graph. But I personally haven't tried negation. However, I think it won't be a big problem if you want to also extract these kind of things into your graph. But I have to try. I have to say the second to the last question, I haven't tried, but I don't think it will be a big problem. Yeah.
All right, great. There's one more regarding the plugin for Tomas. Dennis, I'll add that link in the description of this YouTube video
Yes.
um, once we're done. Thank you so much, Shijing, for doing this session. Really, really exciting session that we did today. Really loved interacting with you, learned a lot. There are just a couple of things that I want the folks out here to take back. Just bear with me for next 1 minute at max. So, if you wish to continue your graph journey, check out Graph Academy. This is an amazing platform where you can get free self-paced hands-on online courses to upskill yourself on graphs and Neo4j. Once you do that, don't forget to take up these certifications. We have two free certifications: graph data science certification and Neo4j certified professional certification. The URL is graphacademy.neo4j.com, or you can scan this QR code out here. For more learning, more content, we are coming up with Notes 23. This is the annual conference that we do every year. A 24-hour virtual marathon of graph content from beginner to intermediate to advanced. Uh, we speak around graphs the entire day, running from Americas to EMEA to APAC, like all the three time zones we cover. We follow the sun and we make sure we bring in the best of graph content for you. So it's happening on October 26th this year. Don't forget to register for it. The URL is there, dev.neo4j.com/notes23, or you can use the QR code to scan it. And we also do a lot of in-person meetups. This is a virtual meetup that we did. We do a lot of in-person meetups as well as part of Graph Database user groups. If you wish to join any of the user groups, go to meetup.com/pro/neo4j. There you'll get the entire list of all the meetup groups, upcoming meetups. Find out the group which is nearby to you and join the group, stay connected, and join us for the in-person networking as well. If you wish to speak at our meetups, any of these meetups, be it virtual, be it in person, submit this very, very short form on dev.neo4j.com/submit your talk. And we will connect with you shortly once you submit it and reach out to you and plan a session next with you. Last but not the least, let's stay with the connected with the community. We have two amazing platforms. So if in case we missed out on some questions from you over here, you can always post it on our Discord chat or our Discourse forum. Any other places wherever you feel you are comfortable, just go to these platforms, post in your questions that you have. Uh, Shijing, I'm sure you might be already there. There'll be also a lot of other ninjas, Neo4j employees who can answer those questions for you and help you move forward with your query. Uh, well, that's it from my side. Thank you so much for staying this long. I know we extended time, but thank you so much, Shijing, once again for doing this session. Really, really exciting session, and I loved um, uh, interacting with you. I've got the links. I'll add these links in the description of this YouTube video. Yes, this YouTube video will be available. This session will be available on YouTube, so you can check back later on the same link. Thank you once again. Bye. Take care.
Thank you. Thank you. Bye bye.